Alright, today. Alright, we're going to take a few notes today. I got two problems I want to cover just to make sure I didn't assign any of these in the homework, but I want to see how well you can do with this. So here we go. Here's what I like you to write down in your notes here to begin with. I'd like you to write that problem down, and then I have a second one that I'd like you to do. The second problem I'd like you to attempt is this.
What section is it?
Attempt or log 5, log 6. Alright.
What section is it?
So, these are from section 3.2, but we're moving on to 3.3 today. So, if you're going to write any section down, write 3.3.
We're kind of
That's the new section going into
these sections.
Yeah. So, 3.3 today.
Yeah.
Okay, the goals today, we're going to be talking about the properties of logarithm. Now, what I mean by properties of logarithms, these aren't those little shortcuts we used the other day to evaluate. These are properties that we can use to expand or contract problems down to something smaller and more manageable. So properties of logarithms. Alright, the goals today, we have three properties I'd like to introduce today. One of which you've already seen, introduced it Tuesday this week. It's called the power rule. So we'll start with that one first. And then the goal is to go through two others, which are the sum and difference formula. So we have a sum formula, which is used on
Jared Kaiser, please come to the office. Jared Kaiser.
That's you, Justin.
a sum formula, which is actually better known as the product rule. If you want to have rules like the actual, if I stay with the same setup. So, product rule. And the third one is called a difference formula.
Wait, are we doing 3 or 4?
6, Lars.
3. Doing 3. Difference formula, which is known as the quotient rule. These are the 3 that we're going to be doing today, and I'll explain them why they suddenly say addition, but they say product, that means multiplying. These things go hand in hand in the actual property. I'll explain today once we get to it. Okay, I have two problems on the board that I'd like you to attempt to try to see if you can evaluate what they are. Find the value of that problem. In this one, I want to know what x is. On that one, I just want to know what the final answer is going to be. So, I'll give you let's give you 2 minutes. 2 minutes or so. Let's see if you can evaluate this and try not to use a calculator.
I like
Okay?
calculators.
Let's see if you can remember the properties we've talked about.
Dane, how are you?
Okay, now, if you want a hint,
Circle method.
you want to do circle method, change that first problem on the left there, you want to change that back to exponential form. The second problem, you just want to evaluate it as fast as you can. Think about what the logarithm actually means.
Is that a 2 or an E? I can't tell.
That is, where?
The log.
Oh, on the other side, that is a 2. So on the right side, that is
I thought that
a
was a 5. I
No,
was just
that's
gonna
a
say
2.
32.
This is a 5. This is a 5.
Well, restart.
That's a 2.
Oh. Yeah, I still don't know.
That makes it so much go error.
Hey, no calculators. No calculators.
No calculators.
No cal.
You can't cancel out.
This is 21st century,
Mr. Ward, we'll rate the 11.
This is 21st century though. I think
Yes,
I can
perfect.
do that.
But his brain is a machine.
I don't know how to do math without a calculator.
Okay, we ready?
No.
Yes.
Alright, here we go.
You said 2 minutes per one.
I
That's
give
like
you-
4 minutes total.
No, 2 minutes. Total. Alright,
Like 1 minute.
circle method. Okay, what this means, what a logarithm actually stands for, base to this power equals the thing that's right behind the base. Okay, that's what it is. That's the parenthesis. Because again, if you're changing a logarithm back to exponential form, a logarithm means a power. So what this thing actually equals is the actual power on the base. So this is 3 squared equals x minus 1. 3 squared is 9. And so your answer for x is 10. That's what it's used for. Now, the second one. Here's my shortcuts for doing this problem. And this is stuff that you should get used to at this
Circle
point.
method.
You're trying to figure out what power can you put on a base that would make 32. 5. So this whole thing means 5. So log base 5 of 5 is 1. Because same thing. You're trying to figure out what power you put on this to make the 5 that's in here. Well, you put a 1 on it. And so your final answer there is 1.
9.
Okay, I picked these problems specifically to see if you remember what logarithms mean, and if you remember the little shortcuts that I was trying to teach you on Monday and Tuesday this week. The goal today is to not talk about necessarily like these little shortcut properties where you can evaluate really fast, but to do other forms of properties with these, expanding, contracting problems down to make it simpler, okay? Or to make it easier to evaluate problems, okay? And that's what we're gonna look at. So, let's start with the power rule, which I think I introduced this on Tuesday, but I wanna make sure that you guys get to see this. So does anyone still need those 2 problems?
No.
Okay, all right, here we go.
Any notes?
First one.
Like the entire year?
All right, here's what we have. Log base 2 of x to the 7th. Okay, what you're allowed to do here is you are allowed to drop the power out front.
7, 1, 2.
So,
Let's just plug that into our calculator.
so what you're allowed to do is you're allowed to drop that out front, and this is what you have. Now, let's talk about why does this work. Why is this the same thing?
We don't know.
Okay, so I'm gonna do a problem where we talk about like actual numbers that are involved here.
Numeric.
So I'll try to give you some numerical examples where it explains like the whole purpose of like what the 7 is. Okay, all right.
7 bananas, 7 booby pies.
So here we go.
Booby pie.
All right.
Look how booby pies.
Long.
It's a
All right, let's just go with-
Pennsylvania.
Let's go with
They're also known as classic guys.
let's go with 2 to the 3rd.